let's get started. Thank you everyone for being here this morning so early. I hope you don't fall asleep. We're here to talk about Ansible. This is the agenda for today. We're going to start by telling you a bit about myself and Pythian. Then we're going to describe what is Ansible very quickly, why you might want to use it, and how to install and configure it. Okay. After that, we'll show some examples of different things you can do with Ansible, including some concepts, and I will show you two use cases. One is an upgrade of a cluster in a rolling fashion, and then a streaming backup and restore, which are some useful things that we automated for our clients. At the end, you'll have a chance of making any questions, or you can stop me if you raise your hand. Okay. So about me, my name is Ivan. You can follow me on Twitter if you want. I am the lead consultant for the open source practice at Pythian, for one of the teams that deals with MySQL. I am based in Argentina, and our company does managed services. So basically, we can help you with anything database related or cloud. So let's start by talking about what is Ansible. And it is really an automation engine, first of all. You can use it to automate your deploys or to make changes to your existing servers. The good thing is based on SSH, so you don't need to install any agent. With SSH, it's enough. It is open source as well. Red Hat bought it in 2015 or so, so there is also a paid subscription option, but for most use cases, you can just use it as is. Or if you need help, you can hire Pythian as well. We can help you. So there's also, Ansible is a command line tool, really. But there is also a web interface that you can use. It's called AWX, and it gives you, in addition to a web browser-based interface, you get a REST API, and that is also open source, and you can get it from that link. There's also Ansible Tower, which is basically AWX with some additional stuff that Red Hat put on it. And you also have to pay for that. So in most cases, if you use AWX, it's enough. So why you might want to use Ansible over other tools like Chef or Puppet, or sometimes Compared. As I was saying before, it's very easy. You don't need an agent. You just need SSH. There are also no firewall rules required. There's no random port that you need to open. If you have port 22, the SSH port, that's enough. It also uses YAML, which is a standard for writing things that is supposed to be easier than JSON or XML. It's up to you if it is really or not, but they say it is easier. It is also secure, as we said, because you don't need too many changes to your infrastructure, and it is using SSH, which is a well-known protocol, right? So let's see how we install this thing, right? First, there is the concept of the control machine, which is the place where you run Ansible from. This can be your laptop even, or it can be a dedicated Ansible server. Myself, I find using my laptop more often than not. The other concept that we have, other than the control machine, is the managed nodes, which are your servers, basically, the servers where you want to operate against. And the requirements in both cases are, as I said before, SSH, and Python 2.7 or 3.5 plus, which usually come built in with your distribution of Linux. So the ways to install, you can use your favorite package manager, Although the problem with that is sometimes the versions are not the latest. So you might want to use EPEL repository, in case you're familiar with it. It has usually the latest. And the thing with Ansible is that it keeps evolving very fast. So sometimes when you are using a module, some new functionality is added. So most of the time you want to be on the latest one. There's also plenty of bug fixes coming out. So it really makes sense to be on the latest and not use the built-in version of your operating system of choice. You can also install using pip or build from source. You have the link to the source code there. How to configure? Well, the first step is we generate an SSH key pair using OpenSSH, as usual, SSH keygen. It usually is a good idea to configure passwordless authentication so that your Ansible control machine can get to all the hosts without the need for a password. And the way to do that is to add the public key to the SSH authorized hosts file. Of course, you have to keep your private key inside your control machine, right? Also, one of the things that I usually do is I review the Ansible CFG file, which is by default located in etc directory. And the two things that I find myself changing most of the time is the host key checking, because especially if you're in a cloud environment, your hosts go down, you provision a new one, and maybe you keep the host name. So you don't want SSH to be telling you that the host key doesn't match all the time. Although it really is a security thing, so up to you if you want to change that or not. And also myself, I am located in South America, so I have a high latency most of the time to the servers that I manage. So increasing the timeout can make sense as well. If you have to run Ansible through a jump host, which also happens very often when you're connecting, if you don't have direct access to the servers, you maybe need to go through an intermediate server, a jump host. So this way, you can run Ansible through a jump host. Basically, you create a file called config inside your profile directory and .sh. And you use the proxy command functionality. This doesn't work very well. So you can tell SSH that to connect to anything.example.com, go through this host first. And these are some parameters that are out of the of the talk, but you can, if you Google this, it will come up instantaneously. Okay, so other topics about Ansible. The inventory file. This is a very important thing. You can use either a static inventory file or a dynamic one. For the static option, you have two formats. You have the ini format and YAML. If you have a small number of hosts, then it probably makes sense to have the static inventory. If your fleet is very large, then maybe it makes sense to leverage the scripts that are available from to use the to run against most popular cloud providers, Amazon, Azure, or Google Cloud. Or even you can write your own scripts to generate the hosts, the inventory hosts on the fly. This is an example of the static inventory. And as you can see, we have the group names between brackets. And you have two hosts here on top, which are called myhost and www.example.com. You can also use wildcards like this. So for example, DBA or BC and so on and so forth. Also, you can have hosts belong to more than one group. And in that case, you can also define host variables, like I'm doing here, or even group variables. And all of them will apply to a host if it is in both groups, let's say. So you can play with that a bit. Okay, so now let's move on to how to use it. The first thing, or the most simple thing, is to run ad hoc commands. This is used sometimes when you need to run a quick command across multiple hosts rather than write a bash script or something. You can leverage the ad hoc mode. And the way to run it is you have to specify, well, the Ansible word and then a host pattern, which can be either a group name from the inventory. As I was saying before, you could say web servers, for example. And then you have to specify the A argument and the actual command. And if you need to do a second level of filtering, you use the limit parameter for that. So first it will filter by host pattern, and then after that you refine with limit. And another thing is the default inventory file is located in etc Ansible host. This is an example of an ad hoc command. As I was saying before, we are running against the web servers, and then within the web servers we want to limit only those that end with example.com, for example. And we are running the df command in this case to look at the disk space, basically. And this is how it looks. You will get a report with the host name and whether the task was successful or not. And finally, the output of the command. Okay, in this case, it's just a single host, but you would get one for each, right? So modules. Modules are another concept of Ansible, and they are basically the building blocks for more complex tasks. And modules help you deal with a specific thing. There are plenty of modules, so if you have to do something, let's say you need to modify a line on a file, for example, you can Google Ansible and modify line in file, and it will give you a module for sure. I mean, there's a lot of modules really available. So what you need to try is to always use the modules in case there is one, rather than write your own script for the task that you have to do. The idea also is that modules are idempotent, so if you run it several times, it should give you the same result, provided you get the same input. For example, in this case, I'm running the ping module, which you can use to verify connectivity from the Ansible control machine to the host. You can see the output there. And the second example is, for example, if you want to make sure that you have HTTPD running, you can leverage the service module, which, for example, depending on whether the distribution is Ubuntu or if it's Red Hat, it will work the same thing. And you are passing here a few arguments, the service name and the state. And for each module, you will get a help page in the Ansible website with all the arguments and some examples, which are very useful. So usually, if you want to do something, you go and check the documentation there, and it will, most of the time, give you a good example that you can leverage. So playbooks. Playbooks are basically how you put modules together to do more complex things. Okay, so it's a way to orchestrate some steps, and like each call to a module is called a play in Ansible terminology. They also have YAML format, and you most likely want to keep the playbooks that you write in a control in a source control repository like GitHub, so that you can keep track of all the changes that you're making, because you will most likely keep working on playbooks as you identify things that maybe you didn't contemplate the first time, or new functionality you're adding. So also, if multiple people are working on automation, it is really helpful to keep them versioned. So let's consider an example here. Let's say that you need to make sure that both Apache and Postgres are installed in servers and are up to the latest version available in the repository. Okay. So how do we write a playbook to do that? First of all, you would edit the inventory file. That is the first step that you have to take. So in this case, I am defining an inventory file that has two groups. One is web servers and the other is databases. And each group has 10 hosts. And you can see that I am using a wildcard there to avoid writing the 10 hosts on a list, right? So once you have the inventory, you can move on to writing the actual playbook. And indentation is extremely important here. So make sure that you respect the proper indentation. Each task here, let's go one line by line, actually. First of all, you have the YAML marker, which is a tree dash. And then you have the different tasks that apply to each host group, okay? So the host groups are the same as we define in the inventory file, right? So we have to do a task for the web servers and another task that will apply to the database servers. You can give each task a name, and in this case, we are using the YAM module. We could use the package module as well. This one is Red Hat specific, of course. And I am passing two values to the module: the name of the package and the state. So this will ensure that you have, like we had to do before, the latest versions available in the repository installed. To run the playbooks, you have to use the Ansible playbook command. And the syntax is very similar to the Adhoc mode that we saw before. You have to give a host pattern, or you can use all, and it will match with all the groups. And you give the playbook name, of course, and you can do an additional level of filtering with a limit argument. Okay. So this is how it looks. It will say all, because I was running against every group. And for each task, it will print the task name. So I suggest that you give all your task a name for easier visualization there. And it will say for each server whether it had to change anything or not. So in this case, you can see that something changed on MySQL 1 server, and for the other server, it didn't do anything. Okay. And at the end, you get a recap with a summary of everything that happened in the run. Okay. So now let's move to the examples part. Let me see how I'm doing with time first. Yeah, we're good. So this is actually the most important part of the talk. We're going to cover two different examples. The first use case is going to be a MySQL upgrade. And the second one, we're going to show how to do a streaming backup and restore. All of this using Ansible. And hopefully you can take something out of this to apply to your own work, okay? So for the first one, we have to consider 3 different MySQL servers, 1 master, 2 slaves. And we're going to follow a rolling approach. We're going to upgrade each slave first, and then we're going to promote one slave as the master, and finally upgrade the former master, okay? Which is a very common approach when you have a topology like this, right? So the first part, let's call this pre-tasks, is we have to make sure that the health of the cluster is good before we start making changes. We have to determine who is the master of the 3 servers. We may need to modify some parameters as part of the upgrade, because maybe some parameter is deprecated or is no longer available, changed name, whatever. And also we are going to have to deal with the monitoring system, because we don't want the upgrade to page on call, right? So for the first task, to verify the health, we are going to call an external script, okay? So the way to do that is use the shell module to run a command. This script is dependent on your topology. You might have Nagios or whatever. So you need to write something that you can run, and it will give you the health, the status of your cluster, okay? One thing that I'm doing here, if you notice, I'm using the register argument, and that helps you store the return value of a task inside a variable, let's say, that you can then reference. So in this case, I'm using that to override the fail condition here. For each task, you can define what is the condition for it to fail. So usually it will be the return code. If it is 0, it's supposed to be okay, but maybe your script returns 0 when it fails. So you can override with this. To figure out the master, again, that will be very dependent on what you are using. So again, we're going to use the shell module and call an external script. The interesting thing about this task is that you can use the changed when argument to control when a task is reported as changed in the final recap. So you can get a better understanding of what changed, because sometimes it will report that everything changed, and that is not really the case. So you can control this on a task basis by using a changed when. Another interesting thing about this one is that, for example, to figure out the master, I want this to run only a single time for every host, because in Ansible, when a task runs, it applies to all the hosts that you gave, okay, in the filter. So for some tasks, it is really not needed to run on every host. We just want a single instance of this script to find who the master is. Okay, so we store in the result of that inside this variable, and we can again control that maybe the task in this case will fail when the script returns the empty string, which means it couldn't find the master, right? Another thing I'm doing here is I am storing the standard output of this task in a fact, which is basically a variable inside Ansible that you can reference later in your playbook. Okay. To get rid of removed parameters, for example, this is the line-in file module will help to do that. For example, in this case, I am specifying that I want to modify my CNF, and I am looking for a regular expression, lines that begin with item, which item is one of these, okay? And then what I want to do is basically comment out that line, and then just print it after, just in case we need to roll back or something. The way to print the previous value is to use this in addition to the argument backrefs yes. Okay. And with items, we'll iterate through this list and replace each value here in the regular expression. So the result of this is that we will remove the lines that say all passwords and InnoDB additional memory pool size. Okay. For downtime, we are again going to use the shell module to call a script, and in this case, I am passing some dynamic variables here. Let's say that your downtime script needs to have the host as a parameter, so you can use the built-in Ansible hostname variable to get at runtime, which is the server name that the task is running against, and run the script accordingly. And we are doing, again, the same thing as before. We want to downtime each service called, let's say you have a service called slave lag and another one called MySQL status. We're going to downtime each. And another interesting thing about this one is that we are actually delegating the run of this task to a different host. So even if the task is being applied to one of your servers in, let's say, database servers group, it's not going to run on the server specifically. It's going to run on a different host. In this case, the Nagios host. Okay, so you can have a different host really run the task than the one that it is the playbook applies to. Okay, so to do the first part, we upgrade the slaves. What we have to do is basically take the slave offline of the pool, replace the binaries, restart MySQL, and run the MySQL upgrade script. Okay, then restart again just to make sure that there are no errors. That is the normal way to do an upgrade, right? So to take the slave offline, again, nothing very automatable here. I mean, we have to call something external. You might have orchestrator, you might have MHA, might not have anything. So we call a script, and then, well, here the become argument allows you to run a task as root. Otherwise, it will run as the user you are running SSH as. And then the service module again I'm using after to stop the MySQL service. To replace the binaries, one way to do it is run, this is taken from the Percona manual actually, to run RPM, and this way you avoid removing the dependencies. Sometimes you have MySQL libs that will be removed if you just run yum remove Percona server, for example, so you can use this. And as I was saying before, the package module, it maps to yum or apt, depending on the distribution you're running. So you can write something that will work on every Linux distribution. In addition to the MySQL or Percona server binaries, you often need to change the extra backup version to match the new version that you're installing. So the way to remove the extra backup package is to, again, call the package module and put state absent. That will make sure that it is removed. To replace the binaries, one way is if the packages are inside the repository, you can call the package module and say state present, or you can manually copy. For example, if you download the packages in a directory here, you can say copy to TMP on the destination host, and then after you can call yum with the local path. It's another way to do it. After that, we restart MySQL with the service module again, which we've seen before. And to run MySQL upgrade, often you need to specify credentials, right? So this is another interesting thing. You can prompt from Ansible, you can prompt the user for input. And if you specify private, it will not show the password, okay? So that is a good thing to do. Maybe the username, it doesn't make sense, but for the password, yeah, we want to hide that, okay? To run MySQL upgrade, we use the shell module again. And another option that we have is, rather than prompt the user, because you might want to run this unattended completely, you can pass the variables on the command line. When you run Ansible Playbook, you pass extra bars, and then you give the credential here. Okay, this is in clear text, of course, but you have the option to do it. Finally, we restart MySQL again with the service module, and the state is restarted. And we upgrade the master. So the same things that we did before, we apply to the master, which is now a slave. Okay. So to do that, we have to call again a script that will depend on what you have to make changes to your topology. And of course, we are going to run that once again. We don't want to run that for every host, because it will do a switch each time, right? And maybe you need to delegate this task as well, so that it runs on a control server that you have. Finally, we need to check the cluster health after the upgrade and remove the downtime that we specify for the services, okay? So to check the health, maybe we want to wait a few seconds so that any alerts are cleared. So the way to do that is to use the wait for module, okay? In this case, I'm waiting 60 seconds, but you can wait how long you need. Again, we call the same script as before to check that the health is now good, and we control the fail condition here. Finally, we remove the host from the downtime that we specified before, and this is exactly the same task as before, but you can run a different script that will remove the monitoring, the host from the downtime. The next example is the extra backup restore over the network. So if you run this before, it means we set up a pipe between the origin and the destination, and then we pipe directly the backup across the network and restore in the destination, okay? So what we need to do here is, first, we need to figure out who is the source, who is the target, maybe downtime the alerts on the target, delete everything also on the target so that we start with a clean data directory. We start the streaming phase, then we do the apply logs, and finally start MySQL and configure the server as a slave, okay? And remove the downtime at the end. So to figure out the source and the target, we might prompt the user, for example, the same as before, using the bars prompt module. And also we can, of course, use extra bars, as we saw in the example before. Rather than prompt the user, just specify on the command line. And also remember to hide sensitive information like the user or password. Also, one thing you can do is you can have a default user here. So if you don't specify one, the default will be used. To downtime the alerts, nothing new here, other than there is a Nagios module in case you have Nagios, so you don't need to write a custom script. You can leverage the Nagios module itself. In this case, you can see that I am doing a downtime for 30 minutes of MySQL service, and this has to run on the Nagios host itself. If you want to learn more about this module, you have the link here. So to wipe the target directory, first we figure out what is the data dir from myCNF. So you can see that I am getting that information here on this line and registering it for use later. And it is also a good idea to have a safety check here, so that if we can't figure out the data dir, the playbook will abort rather than delete something that is not supposed to, okay? Then we stop MySQL with the service module, and we run the dangerous command to clean everything in the database. And this is why we had the safety check, okay? Because if this is blank, you know what will happen, right? Any of you run into this before? Okay. Well, good. So then we're going to do the streaming thing, right? The way to do it is we set up a pipe at maybe port 3306, which is usually open because you're running MySQL there, right? So, but you can use a different port. And we put XB stream to listen after the pipe. And another thing here is that a backup restore is a long task, right? So by default, Ansible is supposed to run tasks that are fast. So in this case, what we need to do is have this task wait until the backup is complete, but continue with the playbook, because otherwise it will just keep the pipe open and never continue, right? Because the pipe will be open and never finish. So the way to do this is to use async and put the expected restore time, an upper limit, really. Like if you know your backup usually takes 1 hour, maybe put 1 hour and a half or 2 hours. After that, if it doesn't finish, it will abort. And with poll 0, it means that it will not wait. It will just move to the next task in the play. Okay? So after this, we sleep for a few seconds so that we are sure that the pipe is established. Sorry. And then on the source server, we run extra backup. Okay? And we pipe the output over netcat. And this, again, runs on the source server only. So here we are preparing the command, because if you have any odd characters, sometimes Ansible gets confused. So the way I found to deal with that is to prepare the command first as a variable or fact, and then do the actual run, okay? After we fire that, we start a task that will check the progress of the backup, and it will retry. It will keep retrying until the job is finished. So this is a way of checking with async status. You can check the value of the task before, and we wait until job result finished, which is what we have here. So basically wait until this is over. After it is over, we do the apply logs, which if you run extra backup, you know this already. And finally, we update the permissions and start MySQL again, okay? Replication. Ansible has a module that you can leverage to set up replication. So first of all, if you're familiar with extra backup, you know there is a file where you can get the replication coordinates when you take a backup. So we parse that file, we get the position, and this is how it looks like, for example. Extra backup binlog position in MariaDB will give you the binary log name and the position. And then we can feed that information to MySQL replication module. This module has a lot of parameters, which you can see in the documentation, but basically we need to give the information we captured before and the user and password. After we have that, this will effectively run a change master command. We run this MySQL replication module again with a start slave, which will run start slave. Finally, we remove the downtime that we have established, and that is all. Okay? So as final words, remember to keep your playbooks on a GitHub repository or whatever you have. Give task a name so that when you have a longer thing, you can figure out what it's doing because it's easy to lose track. Remember to try to use the built-in modules rather than run shell of everything. As you can see, I mean, it can save you some time. For example, the number of tasks, of manual tasks that you have to do for a streaming backup is greatly simplified. This will save us a lot of time when we got this to work. But also be careful, because if you run automation against a high number of servers and you do something wrong, then it has the potential to be a very bad thing, right? There is a check or dry run functionality that you can use. So I suggest that you use that before running the actual thing. And finally, all the examples that we saw here, task by task, you can find them, but a complete version in my GitHub page. So if you take that, I mean, you can adapt it to your environment and reuse it and modify as you want. Okay, this will be the actual full version of the things that we saw task by task, but with in a single file. Okay, that is all. Thank you. Any questions? Yes.
So you use Ansible not only or exclusively as a deployment tool.
Mm-hmm.
How do you incorporate that into your? So you run like daily to check, send the Ansible script to figure out what's the status of the database, what's the.
So, as you said, you can use that for configuration management, like to deploy something from scratch. That's possible. But in this case, the examples that I showed are more for tasks that you have to do, specific tasks, right? It's another way to use it. I mean, you can do whatever you want, really.
Some of the examples look like they also could be used like on daily methods.
Mm-hmm. Yes. By all means, some of these things you can write like mini playbooks to do specific things. I have a lot of those also. Mm-hmm. Yes.
Because I try to run away from that.
Okay. Any other questions?
We have experience with using the Ansible tower. But actually, the thing is how to connect with the key management system or something like that, because keeping a different random password for different databases and trying to use it, it's a little bit tricky. I read that there are some examples, but what is the best practice if you have experience regarding that one?
So with Ansible Tower, what I'm doing so far is creating credentials within it. But I guess you can probably interact with Bolt. Have you tried that before?
No.
Mm-hmm. Maybe check Ansible Bolt. I haven't personally used it, but I believe that it might be possible. Mm-hmm.
Vault works really well with Ansible. I use it. Yeah.
Thank you. Any other questions? Yes?
If you want to execute a command on all of the hosts in your inventory,
Mm-hmm.
connect a few of them or be super user in a few of them using sudo, another one using Prerequisites and this. How can you do that?
So if you use the become keyword that I showed before, you have a way to control what will that do exactly. If it will run sudo, or it will run su minus, or what will it do to become root, right?
Also chose some of them using this become command, some of them using this become.
Okay, so you want to run a task as root in some hosts, but in others no.
A root on all of the hosts.
Yeah.
In some hosts you have to use sudo, and in other ones you have to use another become.
Oh, okay. In that case, what I would do, I haven't run across that case, but maybe what I would do, like thinking now, is run two tasks actually. One with a sudo, let's say, and then filter in the task itself only run it in when host equals wildcard, for example, and the other task when host equals something else. That's how I would do it. Okay, thank you everyone.